Good day, students. Welcome to part 7 of the AP Calculus AB multiple choice practice questions. I'm going to be going over questions 31 to 35 in this installment. All right, so let's see. In the 31, we were told that if f prime of x equals negative f of x and f of 1 equals 1, then what is f of x? This is a differential equation, initial value problem that we can solve by separation of variables, but this notation makes it difficult to really separate your variables. So what I'm going to do is rewrite this differential equation using a much more um, convenient symbol, okay? So I'm going to write this as dy dx instead of f prime of x, dy dx equals, and then instead of f of x, negative y. Alright, so the goal is to separate the variables. X is on the left, on the right, and y is on the left. Integrate both sides so that I can get what y is. Alright? Alright, so to do that, I can multiply both sides by dx and divide by um, negative y, divide by y, bottom line. Okay? So if I multiply both sides by dx and divide by y, I'll have dy over y equals negative dx. Okay? Now that I've separated the variables, we have y on the right and x on the left. I can integrate both sides, and then that will help me isolate what y is. Okay? So I'm going to write this as the integral of 1 over y dy equals the negative antiderivative of negative of dx. Okay, you can put a 1 here if that makes you happy. All right, now we're going to go ahead and integrate both sides. On the left side, the antiderivative of 1 over y is the natural logarithm of the absolute value of y. And that equals, if you integrate just 1 dx, you're going to end up with 1 over x plus c. Okay? All right. Now, you might wonder why isn't there a c here? There could be a c1 and a c2, but you can move the c1 to the other side, and then this c can be the constant for both of them. Okay? All right, so there you have it. Now, what we're going to do next is we're going to isolate y. Okay? So, to isolate y, I'm going to get rid of this natural logarithm business here. So I'm going to exponentiate both sides of the equation using e as my basis. So I'm going to have e raised to the natural logarithm of the absolute value of y equals e raised to the negative x plus c. All right. So on the left side, this e cancels out, and this L cancels out. And then we're simply going to have y equals e to the negative x plus c. Okay? All right, now we can then simplify this a little bit. So what I'm going to do is I can rewrite this piece on the right. I can rewrite this as y equals e to the negative x using the properties of exponents times e to the c. Okay? So there we have it. Now, we also have an initial value situation here. We're told that f of 1 is equal to 1. So if I input 1 for x, the value of this expression is going to be equal to 1. So what I'm going to do is let's say that this e to the c is some constant. We can call it x, okay? Or let's call it, let's just call it c, all right? It doesn't really matter. Let e to the c equal, let's call it c2, all right? So it's just a constant. We don't know what the value of that constant is. You're about to find out. So we're going to have y equals e to the negative x times c2. Okay, if I can find out what the value of c2 is, then I can go ahead and write down my the equation that satisfies the differential equation. Okay. All right. So now I know that f of 1 is equal to 1. So let's plug that in here. So y evaluated at x equals 1 is going to be e to the negative 1 times c2. All right? And that is going to be equal to what? It's going to be equal to 1. So I'm going to solve this equation for c2 so I can plug it into this equation to see what y actually is. All right? So e to the negative 1, using the reciprocal property of exponents, this is going to become c2 over e equals 1. Okay? And if I multiply both sides by e, I'll have c2 is equal to e. Alright? So that tells me that the solution to the differential equation I had before is y equals e times e to the negative x. All I did is I replaced the c2 with e. Okay? Alright, now let's simplify this. I can write, use properties of exponents here again. Put this as a 1. And what do we do here? Y is going to simply be e. Since you're multiplying, you add exponents. E to the 1 plus negative x. Okay? So that simply equals e to the 1 minus x. So your final answer is e to the 1 minus x, and that's option letter C. All right, let's move on to the next question. Question number 32 says if A, B, C, and D and A, B, C, D, and E are real numbers and A is not 0, then the polynomial equation ax to the 7th plus bx to the 5th plus cx to the 3rd plus dx plus e equals 0. Has one root, at least one root, an odd number of non-real roots, no real roots, no positive real roots. Now what we're going to do here is take advantage of the fact that this is an odd power. We're going to look at the end behavior using limits and basically see what conclusions we can draw. All right. So if we're looking at the end behavior of this function, we're going to focus our attention mainly on the biggest on the term with the biggest degree, which is ax to the 7th, because this is what determines the sign, the value that this entire expression approaches. Okay, so since our focus is on ax to the 7th, which determines the end behavior f of x equals ax to the 7th, we're going to look at two cases. Okay, case 1 is when a is negative, or a is less than 0. So what can we say about the limits as x approaches positive or negative infinity? So when a is less than 0, let's underline that. What can we how can we describe the curve as being? So if a is less than 0, the limit as the left-hand behavior as x approaches negative infinity is going to be negative, the negative number, let's just call negative a, times x to the 7th power. All right, so what is this going to be? This is going to be negative a times negative infinity raised to the 7th power. Okay, so what on earth is negative infinity raised to the 7th power? Well, since it is an odd power, we know that any number you raise to an odd power is going to be negative. Any negative number you raise to an odd power is going to be negative infinity inclusive. So it's going to be negative a times negative infinity. Okay? And when you multiply a negative number times negative infinity, the sign will change and you're going to have infinity. All right? So the left-hand behavior is infinity, so it goes up. Now what is the right-hand behavior? What is the limit as x approaches infinity of the same function? Well, remember a is negative, negative a of x to the 7th. What is this limit going to be? It's going to be negative a times infinity raised to the 7th power. Okay? So we have negative infinity. Infinity raised to the 7th power is just infinity. Infinity times a negative number is going to be negative infinity. Okay? So what does this tell us about the nature of the graph? That's the question. So this is what it tells us. Let's make a sketch. Okay, so the left-hand behavior, negative infinity. The function goes to infinity, so it goes up like this. It goes up. And then on the right-hand behavior at infinity, the function approaches negative infinity, which means it goes down. Okay? So since this function is continuous, on this interval from negative infinity to infinity, what can we conclude? It could zigzag at most 7 times. I'm sorry, 6 turns, but we know for a certainty that at a point in time in between negative infinity and infinity, this function must cross the x-axis, which guarantees that there must be at least one root in this situation. Okay? All right. Now, how about the reverse case? What happens if we had the reverse? What if A were positive? What will happen there? All right, so let's consider that also. Case two is what if the end behavior model was negative, had a coefficient that was positive. So case two, what if A is greater than 0? All right. So in that case, let's look at the left end behavior. Limit as x approaches negative infinity of A is going to be ax to the 7, no negative here. So you're going to have A times negative infinity to the 7, and that is going to be equal to um, A times negative infinity, which equals negative infinity. All right. So left end behavior model is left end behavior is it goes to negative infinity, and then to the right, what's the right hand end behavior? You look at the limit as x approaches infinity of the model, ax to the 7th, no negative here because a is positive. So it's going to be a times infinity to the 7th power, which equals a times infinity, which equals infinity. So you notice that there's just a reversal in the signs of the infinities here. So let's give ourselves a graphical representation of this case. So what we have here is as you approach the left end behavior, negative infinity, right here, the function goes downwards. It heads downwards towards negative infinity. Okay? And the right end behavior, when it heads towards infinity, the function shoots up towards infinity. All right? So this can turn at most 6 times. So, well, we know for a certainty that at a particular point in time, this function must cross the x-axis. So we guarantee to have at least one real root in this situation. So in both cases, remember, um, a cannot be 0. It was stated in the problem that a cannot be 0. So if a cannot be 0, it could either be positive or negative, and we've exhausted both cases, and we've seen that in both cases, it must cross the x-axis at least once, hence it must have at least one, real root. Okay? So our answer is option B. Okay, now let's move along to question 33. It says, what is the average or mean value of 3t to the third minus t squared over the interval 1, negative 1 less than or equal to t less than or equal to 2? So you just need to remember the formula for your average value. F average um, is basically on an interval a to b is 1 over b minus a. Now the integral from a to b of f of t dt. Okay. In this case, the lower limit is negative 1. The upper limit b is 2. And our function is 3t to the third minus t squared. Okay. So we're just going to use the average value formula to help us compute what the value of the average of this function on this interval is. All right. So f average is going to be 1 over um, 2 minus negative 1 of the integral from negative 1 to 2 of the function 3t to the third minus t squared dt. Okay? All right. So let's go ahead and evaluate this definite integral. So it's going to be 1/3, and then using the power rule for integration, it's going to be 3t to the fourth over 4 minus t to the third over 3, evaluated from negative 1 to 2. Okay? So using FTC part 2, we're just going to plug in the limits of integration into the function and evaluate what they are. Okay? So we're going to have 1/3 times, we're going to have 3 over 4 times 2 to the fourth minus 2 to the third over 3. This is what you get when you plug in the upper limit of integration, minus, then plug in the lower limits, 3 over 4 times negative 1 to the fourth, minus negative 1 to the third over 3. Okay, close that and close your brackets, googly brackets. All right, so let's go ahead and simplify this. It's just arithmetic from here on out. We have 1/3 times, when you simplify this, 2 times 2 times 2 times 2 is 16. 4 goes into 16 4 times, so 4 times 3 is 12. 12 uh, minus 2 to the third is 8, 8 over 3. And this minus over here, negative 1 to the fourth is just 1 times 3 is 3 over 4. And then negative 1 to the third is negative 1 times negative is positive, positive 1 over 3. Okay? All right, let's go ahead and simplify this further. We can find the LCD, put this over 1. We'll have 1/3 times, and this becomes, if I times this by 3 top and bottom, I'll have 36 over 3 minus 8 over 3 over here. And on the right side, minus, times this by 3 top and bottom, this 4 top and bottom, we have 9 over 12 plus 4 over 12. Okay, a lot of arithmetic here, basic like fraction procedures. Okay, so let's finish this off. We're gonna have 1/3 times, if you subtract 8 from 36, you get 28. So you have 28 over 3 minus, and then 9 plus 4 is 13, 13 over 12. So times this by 4 top and bottom. So you have 1/3 times, to get the LCD, 102 over 12 minus 13 over 12. Okay, and then we subtract that, you end up with 1/3 times 99 over 12. Okay, and then we know 3 goes here 1, 3 goes here 33 times, 3 goes into 33 11, 3 goes into 12 4 times. So our average value is simply going to be 11 over 4. All right, so answer to number 33 is option A. All right, let's go ahead and take a look at the next question, question number 34. All right, so for 34, it says, which of the following is an equation of a curve that intersects at right angles? Every curve of the family y equals 1 over x plus k, where k takes all real values. So you have to just remember the condition of orthogonality or perpendicularity. If two lines are perpendicular, then their slopes are going to be inverses. The slope of one will be the negative reciprocal of the other. So let's say we have this line right here and another line perpendicular to it. So the slope of this line, also known as the derivative, if the slope of this line is m, then the slope of this line is going to be the inverse of m, which is negative 1 over m. Okay, so if this is a condition at every point on the other graph that the slope they intersect at right angles, then we know that their tangent lines are going to be intersecting at right angles too. So this condition of inverse relationship with the slope should hold at every point. Okay, so all we need to do is we need to find a function that defines the slope of this line, and then the inverse of that, a function that can generate the inverse of the slope that the function here can generate will be the slope that defines the other curve, and then we can integrate it to get the original curve. Okay, all right, so this is the original curve y equals 1 over x. So we need to find a function that defines the slope of this curve at every point. And what is that? That is the derivative, right? So we just simply differentiate this to find the slope. at any point, basically x. So m in this case is going to be dy dx, the derivative of this. Let's rewrite this so it's easy to differentiate. Okay, it's gonna be d dx of x to the negative 1 plus k. Okay. All right. Now using the power rule to differentiate this, we're gonna have it's simply going to become negative 1 x to the negative 2, and since this is a constant, it drops to 0. Okay. So if I simplify it, the slope m, which is dy dx, at any particular point is going to be negative 1 over x squared. Okay, so this function can tell me the slope of this curve at any point. So if this function can tell me the slope of this curve at any point, then what do you think what function would generate the inverse of the slope that this function generates? The perpendicular slope is simply the inverse of this function, which is, in this case, is going to be x squared. You take the negative reciprocal of this, because anything that this function generates, this function will generate the inverse. Okay, so there you have it. Okay, so what does this tell me? It tells me that the slope of the other line that is perpendicular to um, this line at every point has a slope of x squared. So dy dx, I'm going to call the other line y perpendicular. So dy perpendicular dx is equal to x squared. So if this is the slope of the line, this is the function that defines the slope of this curve at any point, then what is the curve? We'll just integrate both sides to get what y perpendicular is, all right? So before I go ahead and integrate, I need to separate my variables first. So I have dy perpendicular is equal to x squared dx. And then just simply integrate both sides. And then you're going to have y perpendicular is going to be x to the third over 3 plus c. Okay, so this defines a family of curves that satisfy the condition of being perpendicular to the original curve at every point of intersection. Okay, so if you look at our options, you can clearly see that option D is the correct answer. Okay, and that option D is a case where C is basically 0, and then you just left with x to the third. It could be any constant, but it's going to preserve that property of being perpendicular to this curve right here. Okay. All right. So bottom line, just remember that perpendicular slopes, perpendicular lines have inverse slopes. Okay. All right, now let's move on to the next question, 35. It says a particle starts at rest and moves along a line in such a way that at time t, its acceleration is 24 t squared per second, feet per second, through how many feet does the particle move during the first 2 seconds? Okay, so it's asking for displacement, and we're given an acceleration. So how do you go from acceleration all the way to displacement or change in position? We know that there's a continuum we can keep in mind. We have the position, velocity, acceleration. We have the jerk, but that doesn't apply here. If you're going from position down to acceleration, that's when you differentiate, right? ddt. But when you're doing the reverse, if you're going from acceleration up to derivative, up to position, that's when you integrate, right? All right, so what we're going to be doing is we're going to be integrating in 2 steps. We use the integral of the acceleration function to generate the velocity function, and then from there, we integrate it again to generate the position function and evaluate the displacement from 0 seconds to 2 seconds. Okay, so it's going to be double integration happening here because we're climbing up this step from acceleration to position. Okay, if we were looking for an acceleration at a particular time, we're going to differentiate twice to go from position to acceleration, or differentiate once to go from velocity to acceleration. Okay, all right, so let's go ahead and put this together so it makes sense. First thing I need to do is I need to find the velocity function first. So what's the relationship? If a of t is equal to 24t squared, then v of t is simply going to be the integral of 24t, oh, I'm sorry, it's going to be the integral of the acceleration function. Let me write that down first, okay? So that's the first step I was talking about. Going from acceleration to velocity, we have to integrate first. Okay, take one step of integration. Okay, so if I do that, what is the velocity function? Well, I'm going to have to integrate 24t squared dt. Okay. Now, using the power property of integration, we are going to, this antiderivative is simply going to be 24t to the third over 3 plus c. There goes your velocity function. Okay? All right, so what is c? Well, we know that the particle started from rest. So what's the velocity when a particle is at rest? Is 0, right? So that tells me that v of 0 equals 0. Okay, it's like an initial value. So to find out what c is, I'm just simply going to use this argument. V of 0 is simply going to be what you get when you plug in 0 into this function, which is 24 to the third over 3 plus c. What is this? What should this equal? It should equal 0. Okay? We can clearly see that if we work this out, this entire expression is going to be 0 plus c equals 0. And then we see that c is equal to 0. So we're halfway there. The velocity function v of t is 24 t to the third over 3. Well, let's simplify that. It's 8t to the third. We don't need to add c because c is 0. Okay? All right. So now to find the position, actually, we don't need the position. We need the displacement, which is s2 minus s2 minus s sub 0. That is simply the definite integral from 0 to 2 of the velocity function, v of t dt, right? So what we're going to do is we're going to compute the definite integral from 0 to 2 of 8t to the third dt. Okay? All right, using the rules for integration here, this is going to become, we can even factor out the 8. So we have t to the fourth over 4 evaluated from 0 to 2. Okay? When we plug in 0, we know that this whole thing becomes 0, right? So we don't need to bother ourselves with that. We just, well, let me just show you the steps. So you're going to have 8 times 2 to the fourth over 4 minus 0 to the fourth over 4. Okay? And then this becomes 8 times 2 to the fourth, 16. 16 over 4. And then we reduce it. 4 goes here 1. 4 goes here 4 times. 4 times 8 is 32. So that's the distance that was covered by that acceleration. Okay, so the distance is 40, what is it? 32, sorry. 32 feet is the distance that was covered from 0 to 2 seconds. Okay? So there you have it. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to my channel by clicking up here. Please post a comment to let me know what you think about this presentation. You can click like if you liked it. More clips can be found on mathcoachserve.com. Thanks again and have a wonderful day.